Hey everyone, have you ever wondered how supercritical software, like for an airplane's flight control or a medical device, gets built to be so incredibly reliable? Well, a lot of the time, the secret sauce is a really powerful disciplined approach called the V model. Think of it as a blueprint for getting things right from day one. And today, we're going to break down exactly how it works. So here's our game plan. First, we'll look at the problem that the V model was created to solve. Then, we'll get into its unique shape and its core ideas. After that, we'll see how it actually works in the real world. And finally, we'll ask the big question: when is this super structured approach the right tool for the job? All right, so before we can really appreciate the V model, we gotta understand the world it came from. We need to talk about the problem it was designed to fix, a problem rooted in the way we used to build software and the expensive messes it could create. I mean, this quote just says it all, doesn't it? It's every developer's worst nightmare. You think you're done, you're about to pop the champagne, and bam, a show-stopping bug appears. And with the old school waterfall model, this wasn't just a possibility, it was practically a guarantee. See, the waterfall model is like, well, a waterfall. It's a straight shot down. You have to finish one phase completely before you can even think about starting the next. You do all your design, then all your coding, and only after everything is supposedly built do you start testing. And right there, that's the fatal flaw, treating testing like some final step you tack on at the end. And that flaw? Oh, it has a price tag. A big one. Finding and fixing a bug after the product is already released can be up to 6 times more expensive than if you just caught it during development. We are talking a huge waste of time, money, and let's be honest, team morale. All because testing was left for last. So something had to change. In response to this crazy cost of finding bugs late, a new way of thinking emerged. One that literally bent the development path to pull testing into the process from the very first day. Now, the V model isn't a total revolution. It's more of an evolution of Waterfall. It keeps those sequential steps, but with a game-changing twist. After the coding phase, at the very bottom, the path bends back up, forming this distinctive V shape. And the whole point of this shape is that every development step on the left side has a matching testing step on the right. Its official name is the verification and validation model. It came about back in the 80s with one clear mission: to stop treating testing like an afterthought. With the V model, testing becomes a parallel activity that's happening right alongside development from start to finish. This analogy is just perfect. Seriously, you wouldn't pour a concrete foundation and just, hope the roof you designed will fit weeks later, would you? Of course not. You check the plans at every stage. The V model is just applying that same common sense to building software. Okay, so the V model's full name gives away its secret sauce: verification and validation. These are the two pillars holding the whole thing up. And really understanding the difference between them is the key to unlocking how this model works. If you remember one thing, remember this. Verification, on the left, asks, are we building the product right? It's all about checking our work against the plan. Validation, on the right, asks a totally different question. Are we building the right product? This is about making sure what we built actually solves the user's problem. So let's break that down. Verification is all the stuff you do without running the software. Think of it like proofreading. You're doing reviews, inspections, and walkthroughs of all the documents, the designs, even the code itself. You're checking the blueprints to make sure you're following the plan correctly. Validation, on the other hand, is all about action. This is where you actually run the code. You're doing real-world testing on the final product. The goal here is simple. Does this thing actually do what the customer needs it to do? Does it work? And just to be clear, these aren't just some made-up software terms. Verification and validation are core principles of engineering, so much so that they're written into official industry standards like this one from the IEEE. It just goes to show how critical both sides are. You have to build the product right, and you have to build the right product. Okay, theory's great, but how do verification and validation actually work together in a real project? Let's walk through the V model phase by phase and see it in action. So here it is, the V model in all its glory. That downward slope on the left, that's all verification. It's where we define the requirements and design the system, from the big picture down to the tiny details. And the upward slope on the right, that's validation. That's where we test everything we built. And this is where the magic really happens. Look at how they're connected. For every single design step on the left, you're creating the test plan for its counterpart on the right at the same time. So while the business analysts are figuring out user requirements, the QA team is already designing the final acceptance tests. While architects are designing the system structure, engineers are planning how to test the integration. Then, right at the bottom is coding, the point where the plan becomes reality and we start climbing back up the V, executing those tests we already prepared. Now, with all this structure, the V model seems like a foolproof way to guarantee quality, right? But is it the perfect choice for every single project? Well, let's get real and weigh the pros and cons to see where it truly belongs. The V model really shines when you know exactly what you need to build before you write a single line of code. It's perfect for situations where the requirements are crystal clear and aren't going to change. That makes it a fantastic choice for those high-stakes, safety-critical systems like in aerospace or medicine, where you absolutely cannot afford mistakes and need rigorous documentation. So the biggest pro is obvious. You find bugs early, which saves a ton of time and money. It's disciplined, it's clear, it's easy to manage. But, and this is a big but, that discipline is also its greatest weakness. The V model is incredibly rigid. If a client changes their mind halfway through, it's really hard and expensive to change course. It's just not built for huge, complex projects that are likely to evolve over time. And you can really see that contrast right here. On the left, you've got the V model's clean, predictable, planned-out path. On the right, you've got a model like Agile, with all its flexible, iterative cycles. They're just different tools for different jobs. Agile is built for change and quick feedback. The V model is built for precision and getting it right the first time. And that really brings us to the most important takeaway. In today's world, everyone is talking about being agile and moving fast. But the V model is this powerful reminder that there's immense value in careful, disciplined, upfront planning. It forces us to ask a really critical question for any project we start. What's more important for this specific goal, the flexibility to change on the fly, or the discipline to get it absolutely perfect the first time around?